In this video, I'm going to show you how to use the spiral beam command, which is underneath the poly beam. This creates steel spiral beam. It can basically be used for any helix shaped items. Go ahead and get that dialog open. Um, Bear with me a little bit. It's been a little while since I've used this, but you basically can follow the commands down here. So you're going to pick the start point of the beam, which in my case, I need a spiral beam that's going from this work point down to this work point. Um, so the best way to do this is to just do it in an elevation or in a plan view in the model, and then we can adjust it afterwards. So I'm just going to leave all the properties set this way for now, and then we'll adjust them as we go. So pick start point for beam. So this can be either the high end or low end, it doesn't matter. I'm just going to pick this point here, and then you're going to pick the center point for the spiral. So that's going to be your radius center point. And then for this command here, you can just hit, you don't need to get hung up on what it's asking for. Just do this, the last thing it says here, click middle mouse button. And you can see it gave us something here, not what we want, but we can adjust that. It's going the wrong way and it's way bigger than we want and all that. But so first thing here I'm going to do is rotation angle. So it's set at 270. So what that's doing is saying that the angle from here all the way around back to here is 270. Well, in our case, I put in some work lines here. We'll just pick that. Go there to there to there. So we want our rotation angle to be a negative because we're going this way, 51. So we're going to go minus 51.40167 and modify. So now we've got it going the right way and it should be the right length. Just double checking some stuff here, make sure that it's on the right points here. I'll make sure that I grab the center point, which sometimes it gets a little tricky and it don't grab where you wanted it on the center point. But in this case it did. If it didn't, you can just highlight this and you can just drag this to your where your center point is. Um, then what we need to know is the height of it. So I'm just gonna grab this here, the measure distance. I'm gonna grab this point and I'm going to grab this point. I wanted to keep that because I like it to be as accurate as possible. So here it was 10 inch and 9/32 is our elevation drop. So in this case, we're going down from here. So I want this to be minus 10 inches and 9/32. Modify. Now I'm going to move this whole thing from work point, end point, and I think I might have clicked something wrong because this didn't come in perfect like I thought it was gonna. I'm gonna pause this. think I'm back now. Um, Looks like these work points weren't, I didn't create this model, so I was just making some assumptions here, but it looks like I wanted this to be at this intersection point, which means I want to move this. So this is what I was talking about, where you can just adjust that. Make sure I get all of them so it doesn't do something goofy. And now I think it ended up where we want it. Yep, so now that's in the right spot. And I think that's in the right spot. I'll have to ask the person who modeled this, but I think it was intended to both be along this radius line. After that, it's basically just some cleanup work. We want to adjust this to get the channel towed the right way. That was not right. Back, low, and left. So now we got the back of the channel along the radius line that we wanted it. And back of the channel is at that point. Check that over here too. Channel's at that point, and really that's it. So key takeaways here is you have to have a little layout work done. You need to have your radius in. You need to be able to have some construction lines so you can get this angle, and then you need to know the height. And if it's counterclockwise, it's a positive. If it's clockwise, it's a negative. Same thing with height. If you're going down from your starting point, it's a negative. If you're going up from your starting point, it's positive. Um, the twist angles you shouldn't have to monkey with. You want them to be zero so that this flange is in a true vertical position when looking down on it. Um, Really, that's about it. I'm going to just show a couple drawing tips since I'm doing this too. When you create this, I'm just going to do a quick numbering. Create a drawing for it. So a few things we're going to want to do when we're making a drawing for this. First, I'm just going to load whatever I need here. Being yes. View. To start with, all we want is the top view. Anything else you're going to need to manually do. Top view, this should be a true top view. So I need to view, turn this back on just so I can see what it's doing, and attributes. I'm going to switch this to model. Alright, so now this should be a true top view. So now I'm going to get rid of this because that's worthless. You're going to get rid of all this stuff because that's worthless. Just going to give myself a line here. Top flange. I must have forgot to hit apply. Top flange. Doing this so I can get a degree. Angle. Want a more accurate version of this. Guess that's going to be good enough. So 25.725, rotate, view, 25.725, rotate. Now it's that way. Now I'm going to go 180 because I want to be able to make a view on the back of the channel. So you're going to use this view. You're going to give this all the normal radius stuff, the arc length, the chords, the mid-ords, and whatnot. But for your section, you'll use this create curve section. And you can click a point, click a second point. You always try to get one of these endpoints. Create third point, and then it'll have you grab the extents. Now this should be a true rolled out view. So if we were to just check that, if we use curve dimension, (24, 5 3/8). Did this right? That should be this dimension, 24, 5 3/8. So you can use this. So if you have connections or holes, that's you're going to want to cut sections in this view on that. And then this is the other critical thing. You're going to want to give them the height difference. You're going to need to give them the pitch. And then, like I said, you're going to need to give them this info. Give them a line there. But I just figured since I was doing this, I would show you kind of how to represent one of these. This radius should match your plan radius that you originally laid it out to. And that should be the basics. Obviously, if you have connections or shear plates, holes, all that, you're going to need to dimension all that out, cut more sections and whatnot for all that. But that should give you the basic gist of it. Leave that there for now. All right, I think that's it. Obviously, if you have questions, you can always ask.